Okay, so here we're looking to find the periodic payment of required to amortize a loan of P dollars over T years with interest earned at the rate of R% per year, compounded N times a year. We're going to round that to the nearest cent. So we're given some values here, but we have to be careful on our R. If you're given an R where it's a whole number, you have to change that to a decimal. So this would be equivalent to 0.07. So now all we have to do is plug in our values. So we're going to have our PV is 120,000 times our R, which is 0.07, over our N, which is 2, divided by 1 minus 1 plus 0.07 over 2 raised to the negative times 2 times 8. And remember, if you're using a TI-83 or 84 calculator, you need to put that entire portion into parentheses. And when you plug that in, you should get $9,922.18. So that would be the amount of the payment that you need to make twice a year. Now, another problem we're going to look at is suppose payments were made at the end of each quarter in ordinary annuity, earning interest at the rate of 10% per year compounded quarterly. If the future value of the annuity after 5 years is $60,000, what was the size of each payment? So in this case, we need to figure out what our values are. Now, we're looking at a future value because of what we're trying to do here. So the future value is going to be equal to 60,000. So we're finding this time our R using our future value formula. We need to know our little r, and in this case it's 10%, so 0.10. This last zero is not necessary, but I put it so you understand that that's where the 10 went. The number of times this is happening is quarterly, so that's 4 times a year, and t will be equal to 5. So now we just got to plug in our values. So R is going to be 0.10 over N times our future value of $60,000, because that's what we're trying to reach in 5 years in the future. Plugging that all into parentheses, over 1 plus our R, which is 0.10. It should be a 1. It should be good right there, sorry. Over our N, which is 4, raised to the 4 times 5, minus 1, closing our parentheses here. And remember, if you have a TI-83 or 84, you need to plug in an extra set of parentheses there. When you plug that in, you will get a payment of $2,348.83. Now, if we wanted to look at how much we'd actually have to pay without interest, because this is an interest-bearing account, which saves us actually putting in as much if we wanted to save the amount totally on our own. This would take our future value divided by our N times T. So in this case, our future value is 60,000 divided by 4 times 5, which is equal to 20. We're making 20 payments. And when we do that division, we are getting $3,000. So if we were not in an interest-bearing account, we would be looking at having to save $3,000 ourselves each month versus $2,300. So we're actually saving $700 a month in what we would, or not every month, every quarter, that we would need to be paying in.